and then move to the next goal. NASA actually spent 2 decades of research to have the Mars rover function on Mars. And don't forget, we actually control it remotely if we have to override, and that takes, you know, a very long time to override. So they had to make sure that, you know, all the different rovers were actually quite self-sufficient and be able to plan the missions by themselves. Okay, and there's much more. You know, you would have seen IBM Watson winning Jeopardy, and then being applied to lots of medical domain. We have all those, or actually legal domains. So Watson trying to come up with pretty much solutions to legal and medical problems. Of course, that brings up lots of phenomenal ethical issues as well, but I'm not going to get into those, but happy to take questions about those. Very, very tricky stuff there. Now, within AI, then we distinguish machine learning, okay? Now, 99.9% of the time these days, when you hear those clickbait AI articles that, you know, are talking about the robots taking over and all that kind of rubbish, they're not taking over, don't worry about that, then people are really implying machine learning. They're not implying AI, it's just that they don't realize what the difference is. They actually see that the machine solves a problem and they think it's smart, and it only is to some extent, but there is a big difference, okay? So machine learning is the area of AI that is concerned with, I get given a task, and I want to give the machine an ability to learn solving it better and better all the time. Okay? That's what machine learning is. And I can do that in 3 different ways. Okay? Supervised learning is basically saying, I'll give you billions of examples of a cat picture. By the time I've given you all those examples, you will be able to tell me, if I give you another picture, whether that is a cat or not. Okay? It's what we call classification, essentially. And so Google has been doing the rounds with lots of this tech. Right? Another way of doing this, which is way harder, is called unsupervised. We don't tell the machine whether the images we give them are cats or dogs. We just give them lots of cats and lots of dogs. After a long time, the machine is going to come back to us and say, this bunch is cats, this bunch is dogs. Okay? By itself, unsupervised. And then there's finally reinforcement learning, and this is what I'm a world expert in, which is essentially, I'm going to train an agent. So an agent can be a robot, can be a piece of software, can be a supervisor, can be anything. And the agent actually doesn't get told this is a good thing. They explore the environment around them interactively, and over time they figure out what the good and bad things are, and they develop what we call the best policy to solve the task. So to give an example, Mario needs to get to the end of the level. They start moving around, they die over time, they realize, okay, you know, if I get to this spot and fall down, well, no, that's not such a good thing. If I'm driving a robot in an unknown environment and I smash into the wall time and time again, then eventually I should realize that's not such a smart move, yeah? So reinforcement learning is basically take cues from our own psychology about reinforcement, okay? What is good and what is bad, what is profitable to me, what is not, okay? And through that reinforcement, I actually build my correct behavior and chain of actions. Lots of examples, once again, happy for you to grab the slides and then have a look at all those videos. Number one is what you would have seen hyped on the news. You know, Google beating world champion at Go, and world champion being shattered completely, you know, the robots are coming. The second one is our work on playing Super Mario. You see little Mario being able to complete levels at will. And then you might have seen as well Boston Dynamics robots. So those robots that actually, you know, learn to balance, they're actually kicked in the bum and, you know, made roll, and then they stand up, they grab their boxes and bring the boxes back on the shelves, no dramas, okay? That's taken decades of work, but that's using reinforcement learning as well. Okay, so these are the three main building blocks that we foresee. So we foresee a time where software is going to be in your space, and it's going to be clever about where it is in the space and the sort of interaction that it can provide to the user. So these things are going to come together into some sort of applications that we can already envision. There are going to be many that we haven't even dreamt of yet. Okay? These are some of the things that we imagine can come up. So this is example number one, embodied conversational agents. So imagine your virtual friend who talks to you, or your virtual clerk, or your virtual nurse, or your virtual assistant of sort, except that instead of being on the phone and being just a voice, they are actually a virtual persona who walks around you, does things around you, in the house, in the office, and whatnot. It's a kind of disembodied version of your friendly robot, if you wish, with a big advantage that, of course, it's not constrained by physics at all. They can pop up and out of existence at your command, but they can still execute lots of services for you. Right? Now, one word of wisdom is, one important thing is, this also raises lots of massive, ethical questions around, are we going to replace humans in all these tasks, right? The reality is that, yeah, some jobs will go. It's a matter of fact, okay? Some of the most repetitive, not creative or complex thinking type of jobs will go. It's a matter of fact. Some are going already. Just to be clear, Uber is not in the business of helping people make more money. It's in the business of getting the data from drivers to replace the drivers, just so that you know. So that's what's going to happen. Some of the menial jobs are going. Okay, it's just a matter of exactly when. But the idea behind this kind of tech is to actually have people who are in a job, which is not going to be replaced, have a way of being assisted in the complex logistical or creative tasks that they need to complete or bring about. Okay? So it's about having this, but the human in the loop, not replacing the human. It's a support decision system. Now, I know one or two things about that because my PhD started 18 years ago, so completed 16 years ago, was exactly about this. So this is my PhD work. Of course, it looks really, really funny. It's graphics from 2000, okay, 2001. But we actually had a 3D face. You could actually talk to the face. We actually had text-to-speech as well at one point. And that face is actually a virtual clerk for Amazon.com. That's how Amazon.com looked like in 2001, okay? So we actually have been working on this sort of tech for about almost 20 years, okay? And it's now coming into fruition and will come into fruition in your space, okay? This will reflect on the screen. And this is an example of a game that runs on Microsoft HoloLens called Fragments. It's a CSI game. And lots of smoke and mirrors, so it's not really clever just yet. But it shows how these things are going to work. So the characters in the game are part of this agency. It's basically the FBI, okay? And you've got to crack murder scenes, and they actually understand your living room. So they'll end up sitting on your couch, on your chair, and talking to you, facing you, and all these sort of things. So the first time you play this, you're blown away. The murder scene is actually projected in your room, and what you have to do is to look for clues behind pieces of furniture and things like that. So it's an incredible example of our games are going to be in a few years' time. Other things that we could do is to actually fix Clippy. So this is a similar idea. It's still the conversational agent, But the idea is that the conversational agent is actually helping all of you guys and or me and whatnot in our offices. So there are lots of tasks that have to do with productivity and generating document or creating your code or whatever that could be partly automated or helped by something like that if done well. Okay. So one of the specific sub-cases of embedded agents would be Microsoft was completely ahead of their time with Clippy. And being wrong about Clippy, of course now Clippy is a horrible stain on Microsoft's reputation because we all remember how neggy this was, right? But the idea and the concept is actually right, okay? It's just that back then you couldn't do it. You couldn't do it properly, and so it ended up being massively problematic. This is Job Simulator, a VR game where you actually manage your office. So yeah, it's actually quite hilarious. But another thing that is going to be really big, mark my words, so this is going to be really where things are going to get interesting, is ambient intelligence. So these things, these characters, are also going to start inhabiting your house. And your house itself is going to have sensors in it and software running in it. The house itself is going to be an agent, a machine. And so when that happens, what's going to happen is that when you have this thing on, of course the version 25 or something, then this thing is going to start talking to the house. And so what's going to happen is that, show you a screenshot in good measure. What's going to happen is that when you get close to the kitchen, you'll see weather report on the bench, and then there close to the oven, you're going to be able to highlight that thing and get the recipes to cook in the oven. And then you're going to have your shopping list on the fridge. And there are going to be sensors in the fridge. So the shopping list is going to be smart and say, look, I think you're forgetting to buy the oranges. You probably should. Okay? So things like that. Of course, the use case that I always have there is, remembering to buy something for your kids. Okay? Is that something that we all forget? So that's my little girl, who's very high-level ballerina. So, I always keep forgetting buying shoes for her. So imagine I rock up to a room and then the house reminds me, oh, you gotta get the shoes, right? And so what you can do there is, not only you can do that, but then you can hop online, look up the catalog. Catalog is in front of you, grab the shoe, do actually a virtual fit on the foot, and then order the shoes. Yes, that's what's going to happen. It's just a matter of putting all those ingredients together. The technology is there. We got to mesh it together. Okay, it's going to be a complex engineering task, but can be done. One other app that we've all tried, I assume most of us have. Yeah, I can see people smiling. Is the IKEA app. So that's working today in your house. You actually have the IKEA catalog. You can project and see, okay, can the couch fit in that corner? That sort of thing. So that is the super rudimentary version of what I'm talking about. Not very smart, does only understand the space, and you can try and fit it, but not much else. Okay? What I'm talking about is really understanding the context of where I am in the house, and then different parts of the house really remind me and connect me to my daily tasks and things. And of course, you can envision a version of that for the office. Of course, I took the house because house is what we are more familiar with. And then finally, if we actually scale this to an even bigger scale, we can imagine this being big as the whole world. Okay? And so not only do we get prompts in the house, we get prompts in the street. So you could imagine directions in the street. These days you use Google Maps. You might be strolling in the street with your glasses, and you'll get directions for where you want to go next that are augmented reality, flashing arrows going, okay, that's where Flagstaff is, that way. Google, believe it or not, has actually given a concept video, which of course is not true, but it's a concept video of how Google Maps is going to work in a few years' time, and it's exactly like this. So all the directions and light trails on the ground guide you to where you're going to go next. Okay, it's not on your phone. It's actually here. You can see it and you move around. And in fact, our app in the library works exactly like that. You know, you get to the spot and then it tells you, okay, next spot is actually that way, and you get the trail and follow the trail. Okay, so we are pretty much there. Now the tricky bit is going to be that, however, there is lots of infrastructure that we need to put in place to make it work systematically, because we have to remember that all these virtual objects have to persist in physical spots pinpointed physically to every single spot in the world. Okay? So it's a phenomenal amount of data that we need to keep track of. But this is something that our sci-fi writers had actually imagined many years ago. Okay? This is what we call the VR or MR grid. William Gibson actually created cyberpunk, single-handedly with Neuromancer, very well-known book of science fiction, and Neil Stephenson with Snow Crash, and of course, those actually spurred The Matrix a few years down the track. And in fact, the term Matrix comes from William Gibson's book, The Neuromancer. That's how this virtual stuff superimposed on the world was actually imagined to be a matrix. Yes? Like this. So this is probably the very large scale. And then of course, finally, we have lots of games that are going to exploit this, and they are at very different scales, yes? So Pokemon Go is already at this world scale. You can't do much, right? You rock up to a spot and then try to capture the Pokemon, off you go to the next. So it's very simplistic in its own way, but it's actually made some progress in terms of saying we pinpoint the world and we attach things to those locations. But of course we have other forms of MR in games. So this is one thing that I'm going to show you now. There's only a few slides. I'm going to run the whole lens and show you this game, Roboraid. So you'll see projected on the screen what I see, and we'll see creatures popping out of the wall, okay? Even though there is no hole in the wall, yeah? This is a game, this is the sort of augmented reality version of Tamagotchi. Essentially, it's called Dragon. So the company responsible for this, Playside, the CEO is a former student of mine, and they actually work with Electronic Arts. They are the first VR studio as well. They're in town. So, but this is really interesting because it's essentially what Tamagotchi looks in this new era. Right? Tamagotchi is there in front of you, and you feed him and give him virtual water or whatever, and they actually hop around your table. They are there with you. So it's a much stronger emotional connection. And this has been doing the rounds as well. Beat Saber, right? I see people going, yes, I've played this. So this is probably the best VR game at the moment. This is meshing up Guitar Hero with being a Jedi Master. So essentially what happens is the blocks come to you at Sound of Music, and then you use the controllers to slash stuff. So it's actually extremely powerful, and it's a very good indication of a game that is using virtual content, but physically locating all that and making you physically active in the space. Okay, so you can do it. You're actually tired after playing this at the high level. So it's actually really, really interesting. So to sum it all up, and then we'll get into a quick demo. And I'm happy to take more questions as well. There's more R&D needed to make this vision happen, but most of the building blocks are there at the bare minimum to some extent. Now, what we need to start worrying about now is, of course, wrapping up some of the research challenges. There are some, but also how do we make all those engineering problems more solved or solvable, but also look at the phenomenal and staggering amount of ethical implications of this, ethical and social, okay? As I said before, it's not a question of whether some jobs are going to go, or not, it's how many are going to go. It's also there's no question as well that having this software that lives here with you is going to change our perceptions as human beings. Okay, but then again, the introduction of machines in the 1800s changed our perception of how the world works. Right, before having machines that could automate stuff for us, we were not working that way. So of course, everything is a bit of a blank slate. We need to be able to preempt this process and make it a good one for us. Yes, so we need to start talking about social and ethical implications, engineering, and solve the research. Yes, question.
How long do you think it is before we reach artificial general intelligence? And are there some principles enough to
You want me to make the very big prediction, the singularity. I don't believe the current prediction, say Kurzweil, right, has been the one who's been giving singularity predictions forever and ever. And of course, they were all very aggressive and they haven't come to pass. I don't see how general intelligence could actually come about any earlier than, say, 15, 20 years, to be honest. The main reason for that is that we actually are phenomenally good at some given tasks. So, we have improved a lot in terms of machine learning, and particularly with respect to recognizing speech and vision, recognizing images and shapes and whatnot. But that's not intelligence. That is what we call pattern recognition. I see something, I recognize that's something. So that's how a parrot works. So the level of AI that people are worried about these days is the level of a parrot. So shouldn't be concerned about general hype about general intelligence. For us to be able to get there, we need to get our reasoning capabilities and our common sense reasoning capability way higher than they are now. But as you might imagine, is a phenomenally daunting task, right? I can scan these chairs, but how do I teach the machine that this is a chair? And what does that even mean in terms of the physics and the affordances that it's got? So there is, I think, different AI, people have different views around this, obviously. There are people who think everything can be learned. Despite the fact that I work in machine learning, I don't believe that. I believe that at the end of the day, we're always going to have some human engineer in the loop. We'll actually somehow have sophisticated tools to be able to provide knowledge, buckets of knowledge to the machines. And so if you ever seen Westworld, the reboot, you've seen lots of engineers there scripting behaviors and giving knowledge to the robots. That's how I think it's going to work. They have very sophisticated tools, but at the end of the day, it's really, really impractical and very hard to believe that the machine is going to learn everything from scratch and be very efficient at that, okay? Unless we potentially crack the way we work first, okay? But I don't see that happening in the next 20 to 30 years either. So yeah.